Okay, welcome to this demo on how to explore some of the hydrology tools in the Spatial Analyst Toolbox. So, hopefully you have already downloaded the data from Beachboard, and I've provided you with a folder called Spat Hydro, short for Spatial Hydro. In that folder, you have the Laguna Beach DEM that we used in a previous lab, and you have another grid which is in a DRG format. It's actually a digital raster graphic that is a basic scan of the quadrangle map so that we can use as a backdrop. So I'm going to load in my DEM, and I'm going to load in this TIFF file. It's in a different coordinate system, but because it's a DRG, we can't project it. So that's another thing to consider. Things that are raster graphics like this can't be projected, but we can project them on the fly just by accepting the transformations. And you'll see that it underlays nicely with the data set. To explore the underlying TIFF just for data exploration, I've loaded my effects toolbar on my menu. I'm going to right-click and turn it off so you can see what happens when you right-click and turn on your effects. With the lag DEM as the target layer, if I click this swipe tool, I can go down and up and down and up. And as I zoom in, I can see what's underlying the DEM according to the USGS quadrangle. So that's just a little tip. Okay, the purpose of this part of the demo is to demonstrate sink filling or filling a DEM. Now, as you recall from the lecture, we are required to have a hydrologically sound DEM, meaning the DEM can't have any grid cells that are sinks, meaning cells all water, if it were to travel from one grid cell to the next, would fall into a sink. And the understanding or the assumption is that there are no naturally occurring sinks in a DEM that's a 10-meter grid cell resolution. So we'll take that at face value, because what we basically need is a hydrologically altered DEM so that we can run flow direction on the grid. Okay, so I'm going to click the fill command. The input surface raster is the lag DEM, and I'm going to have my filled DEM output to my folder, and I will put it in the folder for this lab where I've given you an output folder. So I've navigated to the output folder, and I will call it lag fill, so that we know that this is the Laguna Beach filled DEM. Okay. So the output surface raster is the surface raster of this after the sinks that have been filled, and I'm going to click OK. Okay, now we have a filled DEM. If I toggle on and off, it's very difficult with this kind of symbology to see what the difference is. If you look at the range, it looks like the lower values have the highest value hasn't changed, but the lower values are slightly different, which makes sense because you're altering those lower values so that you fill them so that there's no flow so that's stopped up in the DEM. But if we want to actually explore how filling the grid impacts or changes the original raster, what we can do just as data exploration, just to give you this understanding of filling is required because we have to do it in order to calculate a flow direction grid. You can't calculate a flow direction grid on an unfilled DEM. You'll see that in the next video. But to explore how this original DEM was changed by the fill process, we can go into raster calculator and calculate the difference or the absolute value of the difference between the filled and the unfilled DEM. This process is something that we often do if we want to explore the difference between two grids, and the result is often referred to as a residual grid. So I'm going to take the absolute value, meaning if any cell changed, it will have a number. It'll have the number that's the difference in elevation between the two grids. But if no cell changed, it'll be a 0. So the result grid will let us see where the grid was altered. So I'm going to take my lag fill and subtract the lag DEM, and my output raster I will call resid fill, just for us to see what the difference looks like. And here we have a grid where anything that's not 0 has been changed. So any of the white colors here, high values, have been changed. So if we want to zoom in on an area that's been changed or altered because of sink filling, and then we want to scroll down and toggle if this works, it's not working, that's not good. That's because I want my fill grid to be the target, and I want my lag DEM off. I just want to see my resid fill and the TIF. So sorry, now you can see real time how to fix things. So I have my resid fill as my target, and I can see what's happening underneath, and it's the San Joaquin Reservoir. So the original DEM needed to be smoothed or filtered by filling so that any grid cell in the original DEM flows into the San Joaquin Reservoir. So this is just showing how the original DEM was altered so that all cells will flow into the reservoir. So now we have a filled DEM. We don't need to use our resid fill anymore. That was just an exploratory grid to save for future reference. But what does this show us? In the lecture, I talked about the pitfalls of sink filling. That sink filling is a necessary evil. I don't know if I like the term evil, but it's a necessary thing that we have to do in order to run any of the hydrology tools, and in doing so it alters the original DEM. So it's important to recognize what you do to your DEMs before you then do subsequent analyses on them, as has been a consistent theme in the class with you to date, so hopefully you can appreciate that. Our residual grid shows us what changed when we performed the fill function from the original to the filled DEM. Moving forward in the next video, we'll have to use the lag fill DEM in order to perform the hydrology functions. So stay tuned for the next video.